Oh my goodness, friends, one more time. Here we go. Here we go. Now, we've been through all kinds of fun, handy dandy little things together. This next thing, we're getting close to the end here in chapter 2. This next thing, we're going to be looking at something called implicit derivatives. What in the world does that mean? So that's what we're going to be kind of taking a look at today. What the stink is an implicit derivative? So let me show you kind of where we're going with this here. If I do that, if y'all don't mind. I didn't want that color. I wanted this color. Perfection. All righty. Now, let's say I give you a circle. I know it's not a perfect circle, but you know it's close enough, right? And you guys are smart kids. You can come up with the equation of this circle pretty darn quick. And equation of this circle, let's make it, how about x squared plus y squared equals 25. Now, this isn't a function, and we all can say that, but what if I were to take the point? Take the point, let's go with the point 3, 4. 1, 2, 3, 4, right here, like that. And friends, what if I asked you guys to tell me what is the equation of the line tangent to the circle at that point? Well, the problem we have here is we have two variables. We have x squared and a y squared. It's not a function, so it's not in terms of y, so I can't do a derivative like I normally would do. And that's where we have a little 4-step process that we use to help us find implicit derivatives. The first part, we're going to differentiate both sides with respect to x. We're going to take the derivative of both sides with respect to x. The next thing, we are going to get all our dy dx's on one side. You're like, what in the world is a dy dx? I'll tell you in a second. We're going to then factor out dy dx. The last thing, we're going to solve for dy dx. And again, I can hear it right now. Dy dx, not sure I know what that is. You don't need to, don't worry about it. We'll be okay. So this is going to be what we're playing with today. All right, so I need a couple black lines here because these are going to be fractions. Okay, so everything's is always changing according to something. We always have to have a constant that we say life is changing towards this. Now, usually in real life, we would say that is being with respect to time. And we use time as kind of that constant idea that we have everything changed to. But what we're going to do here, friends, is we're going to have everything, since we don't have time, we're going to have everything compared to with things changing with respect to the x-axis. In other words, if I take my derivative, I'm going to take my derivative just like normal, but I'm going to take everything with respect to the x-axis. So d of x, so the rate of change of x in terms of x. That's what that says. Plus 2y, and I'm taking the rate of change of y with respect to x. So again, I'm going to come back here. 2x squared. So 2x, that's our derivative. And we took the derivative of x with respect to x, plus 2y, the derivative of y with respect to x, dy dx. And then 25. Any constant number, you guys know it's one of my favorites, is 0. But let's think about this just one more itty bitty teensy bit. Taking x with respect to x. Back when we were in 3rd grade, we found out if we're dividing things, the same thing on top as the bottom, dx over dx, that's really just 1. So we can, instead of putting dx over dx all the way through, we're just going to leave that off because it's not needed. So 2x, 2y, dy dx. So derivative of y squared is 2y. And we took the derivative of y with respect to x equals 0. So now the next part about this is, second thing, it's all the dy dx's on one side. So this 2x, it doesn't have a dy dx. So it's going to go to the opposite side. 2y dy dx. Remember, dy dx is another way we said we could also write a derivative. It's the same thing as f prime of x. Just not the one we use very often. And then the last thing, third thing, factor out of dy dx. I only got one term, so I skipped that. And the last part is factor out or solve for whatever's left. Now that is a very interesting way to spell solve. I'm not gonna lie. How about we fix that real quick? There we go. All right, so whatever's left, now we're gonna go ahead and divide everything by dy, by whatever's with dy dx. So I'm going to divide both sides by 2y. And if we do that, notice we get a dy dx, or in other words, the derivative of y with respect to x. So we get a derivative, a first derivative, that allows us to be able to compare and calculate the instantaneous rate of change. When we're dealing with functions, or we could just do an explicit derivative, just our regular old f prime of x. But when we're dealing with different relations that we can't solve for y, we end up doing this thing called an implicit derivative. And it's kind of a backwards approach to still get dy dx, or get a derivative to be able to evaluate it. And remember again, that f prime of x is the first derivative, but it's pretty much still the same thing as dy dx. These are the same things. So I have this dy dx to be able to actually evaluate what that rate of change would be. Now, friends, realize when I'm trying to figure out how to evaluate with respect to that, we have to make sure that our form is right. And so whenever I do this, I'm going to put a line here. I'm going to put x, y, and then whatever my x and y are, I'm going to put them. We have to have proper form when solving this. So I'm going to use that form now so you see how it works, okay? So I'm going to determine the rate of change at that point, 3, 4. So to figure out the equation of that tangent line, I'm going to go ahead and do my evaluating of my slope. So x and y, and in place of x and y, I'm going to plug in the point 3, 4. So this is the form. So, and it says I'm going to differentiate with the derivative of y with respect to x. I'm going to plug in 3, 4 in for x, y. So I'm not just plugging in one value for x because I have both that are still there. So I'm going to plug my 3 in for my x, and plug my 4 in for my y, and I end up getting my slope, or my instantaneous rate of change. So now, friends, we have our slope, we have our point, we can write the equation of the tangent line. So if I want to bring this all the way back, now that I know what my slope is, and now I know where the point is, if I wanted to, I can go ahead and tell you what the equation of that green line is, the circle. So y minus 4 equals negative 3/4. Well, that kind of makes sense. It's a downward, it's a decreasing line, x minus 3. And that'd be the equation of a tangent line. So this idea, well, we're not going to draw the picture, but I wanted you to see kind of what's going on here. We can't always take an equation and get y by itself every single time. Sometimes it takes a little bit of work, right? It takes a little bit of work, and that's okay. So here's what you guys are going to do here. I'm going to have you guys try this dy dx thing. Undo, I want to do that. And we'll bring that back here. So here's the problem I'm going to give you guys. Let's see what you guys can do with it. I'm going to give you, let's erase a little more. Why don't you guys try x squared plus 3y squared minus 4x plus 7y. So we're looking at some sort of ellipse here. Equals 1. Now I don't need to solve for y. I'm just not going to do that. See if you guys can actually determine what that'd be. I'm going to write another problem up here for the next one for you guys. So while you guys are doing that, go through a little process, make sure we have this all under control. Let's see. Alrighty. Okay, let's try it. So the first thing we're going to do is we're going to take the derivative of every term. So x squared, well, that'd be 2x. 3y squared, well, that'd be 6y. But remember, that was a y. So at the end of each time we take the derivative of y, we're going to add dy dx. Negative 4x, well, that's negative 4. Plus 7y, so that's 7 dy dx. Equals 0. Now, I've got to separate my terms. So part 2 says get all the dy dx's on one side. So that means the 2x and the 4, they can go to the other side. Or I can move the dy dx's to the other side. It doesn't really matter, honestly, to tell the truth. You guys figure out what makes most sense to you. So plus 7 dy dx's. So all my dy dx's go on one side. And everything without a dy dx, that goes on the other side. Number 3 says factor out the dy dx. Well, in this case, there is something for me to factor out. That's the wrong shape. That's the right shape. So now you can kind of see where this factoring out part is going to come into play here. You see how they both have their dy dx? So we're going to factor out that dy dx. And we'd be left with 6y plus 7 equals 4 minus 2x. And then to solve for dy dx, we're always going to end up dividing out whatever's next to it. So the 6y plus 7 goes away. dy over dx equals 4 minus 2x, or some of you probably have negative 2x plus 4. And if you move the dy dx to the other side, you might have everything just with the opposite sign of what I have, and that works. That's okay. As they give you the same equivalent value, we are good. There's your derivative. All right, friends, why don't you try this next one? See if you can find the derivative of the next one. Be careful, though. I'm going to give you one little hint. Here's my little hint. This is 2xy. That's 2x times y. Be careful on that. Go for it. Don't worry about doing the evaluating, though. We'll do that together. So pause it. Go ahead and do it. All right. Hopefully you've unpaused it. You've solved it. Let's see if we can do it together. So x squared, well, that's 2x. Now notice, on this one, I have a first term, that's 2x. I have a second term, that's y. So I'm going to do the product rule for this. So 2x plus first term, 2x, times the derivative of the second term. So the derivative of the second term, the y, is 1 dy dx. Plus the second term, that's the y, times the derivative of the first term. So the derivative of the first term, 2x, its derivative is 2. So I had to do a little product rule in there. So y cubed then is 3y squared dy dx. And the derivative of 13 is 0. All right, got to kick out some terms now. So let's see, I'll leave my dy dx's on this side. So I have 2x dy dx. I have 3y squared dy dx. And on the other side then, let's see, the 2x got moved over, so that became a negative 2x. The y times 2, the 2y got moved over, so that's a negative 2y. Factor out my dy dx. And I'm left with 2x plus 3y squared. And then we're going to divide by it. So dy over dx equals, friends, negative 2x minus 2y all over 2x plus 3y squared. So we have our expression. Now we can go ahead and evaluate. So friends, why don't you pause the video and evaluate this for 1, 2. Use proper form. All right, now you guys had a chance to do that. Here we go. Dy over dx. Gonna make sure I use my proper form to evaluate. So there's my line, x and y. I'm going to replace with 1 and 2. And it's a big, giant plug and chug. The nice thing is, if this was on the free response portion of the test, once I plug my numbers in, I do not have to simplify. I will leave it alone. The free response portion of the test, I simplify nothing. So I leave them alone. So all my x's are 1s, all my y's are 2s, I would not simplify that on the free response. Multiple choice, I'm not going to have a choice. I have to. So -2 minus 4 all over 2 plus 12. So that's -6 over 14. And -3 over 7. But again, if this is the free response portion of the test, I am not going to simplify any of that at all. I just leave it be. Okay, well, hopefully you guys are starting to kind of get this a little bit. Let's try a couple more of these, really make sure we hammer it home here. I want you guys to have a real good solid foundation on this, because the next couple classes we're going to apply this to real life settings. So 3x squared minus 4xy plus y squared equals 7x. And then I'm also going to have you guys do sine of x plus y equals 5x squared. Now, go ahead and pause the video here and see what you can do with this. Okay, so as you guys are going through, just so you're aware, there's one thing that everybody kind of makes a little mistake on, and it's this right here. Be very, very careful with that negative. Just make it a -4, so you have -4x times y. My little hint. All right, go ahead and finish that up there. All right, now that you've unpaused it, let's try it here. So 3x squared, that'd be 6x. So this is what I'm talking about in this one. Got to be very, 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 very careful. -4x times y. So here's my, I'm going to come to it now. Here's my product rule. So first, so -4x, so that's -4x times y, so times the derivative of the second. So y would be 1 dy dx plus second, so plus y times the derivative of the first, times derivative of -4x. And this is where a lot of people forget to bring the negative in it. They make it a positive 4. Very, very, very careful with that, friends. All right, so plus 2y dy dx equals 7. All right, so all the dy dx is on one side, everything else go to the other side. So I'm going to move the dy dx this time just because I feel like doing something different. 6x minus 4y minus 7 equals 4x dy dx. And minus 2y dy dx. So we're going to factor out our dy dx there. So 6x minus 4y minus 7 equals dy dx. And again, if all your terms have opposite signs of my terms, that is totally okay. This means you moved your dy dx's to the other side. And then when I divide, 6x minus 4y minus 7 all over 4x minus 2y. All right, all right. Let's see how you guys did on this one. First of all, notice this one's a chain rule, right? Look at this. I have an outside function. So the outside I have is cosine. So when I do my derivative, I only change one thing at a time, x plus y. And then I'm going to take the derivative of the inside function. So the derivative of x is 1. The derivative of y is dy dx. And the whole thing then is equal to the derivative of the other side, 10x. So now we got some things we can decide to do here. I'm going to go ahead and just divide out the cosine xy. Because the whole point is just get dy dx by itself. How you go about doing that, it's on you. A lot of times it's factoring. This is one of the rare times it's not. So 1 plus dy dx equals 10x over cosine of x plus y. The last thing you got to do is just move that 1 over. Dy dx equals 10x over cosine of x plus y minus 1. All right, friends, no harm, no foul there, huh? No harm, no foul. So hopefully we're starting to get the idea of what all this looks like for implicit derivatives. So we can find the derivative. We've already seen we can use it to find tangent lines and all that kind of stuff. So all that kind of stays the same. None of that changes. But if you remember, we also had second derivatives as well, higher order derivatives. Well, it turns out that we also have second derivatives for implicit derivatives. Now it requires us to do one more thing. That's not a big deal. So before we do that though, let's make sure we understand what for an implicit derivative, the second derivative, the notation looks like this. It's dx d squared y over dx squared. This is our notation for second derivative. Third derivative just changes 2's to 3's. Fourth derivative, 3's to 4's, and so on and so forth. But this is our second derivative. So I'm going to have you guys first start off, just find the derivative of this function. Find the first derivative of this function. Okay, go ahead and pause it, and then I'll join you in a second. All right, friends, here we go. So 2x. And then our personal favorite, we got another product rule here. Loving those product rules. So first times the derivative of the second. Plus second times the derivative of the first. All right, so plus 2y dy dx. Equals 0. All right. So anything that doesn't have a dy dx goes the other side. So we have, what do we have? X dy dx. So far, everything hopefully should be staying pretty much the same. Equals negative 2x minus y. Factor out our dy dx's. That was kind of a weird little 2y deal. I can hear you all screaming at home, Williams, the 2y. Yeah, I made a little. That's what happens. My 6th video tonight. That's what happens when you make 6 in one night. All right. X plus 2y, thank you, equals negative 2x minus y. And then we divide out the x plus 2. So dy over dx. So this is our first derivative. Now notice our second derivative is going to be a quotient rule. And you guys all see that. So let's see if we can do the quotient rule. So here we go. So d squared y dx squared. So I'm going to have a quotient rule showing up my second one. So here's my top function, right? And here is my bottom function. We're going to use our quotient rule on it. So as we're dealing with this here, so we have the first, or the bottom, so x plus 2y times the derivative of the top. So negative 2x, oops. So derivative of negative 2x is negative 2 minus derivative of y, so that's 1, but notice it's going to be 1 times dy dx. So negative dy dx. Minus top negative 2x minus y times the derivative of the bottom. So we have 1 plus 2 dy dx. Oh my goodness, this thing has just gotten ugly. Just gotten ugly. It's all over the bottom squared. Obviously, friends, and this is where we're really thankful, we will not simplify this. So don't go, oh no. Yeah, I wouldn't simplify it either. But there is one big problem we have here. Can you guys see the problem yet? Take a look at it. dy dx, dy dx. Well, I can't really have a dy dx. So we have to go back and try to remember what was dy dx. Well, it was that. So we're actually not quite done. There's one little thing we have to do. And I say little, it's ugly, right? In place of those dy dx's, I need to go back and plug in what dy dx was. I don't have to simplify anything, thank goodness for that. But I do have to plug all those in. So here we go. Let's plug all those in now. I have x plus 2y. I have negative 2 minus, plug in my dy dx now, negative 2x minus y. Again, we're not going to simplify this, so don't kind of freak out about it. I know that tends to be what people do. They're like, ah, no. Yeah, I know. I get it. These are some ugly answers. minus negative 2x minus y. One plus 2. Oh, we got that dy dx thing again, so we gotta go ahead and plug that back in. All over x plus 2y squared. All right, so I wanted you to see a second derivative. They're not pretty, for sure. I'm going to give you guys a little bit easier one to do because I'm going to have you actually evaluate it. Okay, so here's what you guys are going to get. I want you to evaluate d squared y at the point, let's give you guys 1, -1, given x cubed minus plus, I lied, plus y squared equals 2x. All righty, friends. Why don't you guys go ahead and pause it right now and just find just the first derivative. Don't go into the second derivative until we know it's right. All right, just do the first derivative. All right, I got you back now. Here we go. So we have 3x squared plus, that's a 2y dy dx. Kind of an ugly 2 there, wasn't it? Two y dy dx equals, oh, well, I'll tell you what. Why don't you guys pause it right there? I forgot that I changed my problem to be 2. It doesn't change the value. The other one would have worked. Why don't you guys go ahead and pause it real quick? Try that. Make the numbers a little bit easier because I don't want to kill you guys with the numbers. All right, I got you back again. Yeah, you didn't pause it, did you? That's fine. All right. Yeah, no, I don't want to, I want you guys to more get the idea of how this works. I don't need you guys having to deal with ugly, ugly numbers to do it. All right, so negative 3x squared. The dy dx by itself. Into with negative 3x squared over 2y. All right, so hopefully you got that. All right, friends, go ahead and find the second derivative. Go for it. Pause the video, unpause it when you're done. All right, here we go. So the second derivative, so d squared y over dx squared so here we go. We're going to have the bottom 2y times the derivative of the top, which would be a negative 6x, minus the top, which would be a negative 3x squared, times the derivative of the bottom. So the derivative of the bottom would be 2. Oh, here's that dy dx part again. Not like that part last time. And the whole thing is going to be over 2y the bottom squared. All right, so look, before we can plug our numbers in, we have to clean it up. I don't necessarily know it's going to be too terribly pretty. So we end up with 2y times negative 6x. I'm going to go ahead and clean it up a little bit like this, since I am going to have to plug some numbers in. Plus 3x squared times 2, so that'd be plus 6x squared. And then we have the dy dx that's got to come in here. Negative 3x squared dy dx. All over 4y squared. Friends, we're going to plug in our value. We're going to call it a night. D squared y dx squared. And we're going to plug in for x and y 1 and negative 1. So negative 12. And again, free response portion of the test, we are not going to go through and simplify anything. We can't say that enough. We are not simplifying anything. So every place we see an x, we're going to plug in 1. Let's see, so there's a 1 there, there's a 1 there, there's a 1 there. Every place we see a y, we're going to plug in a negative 1. There's a negative 1. There's a negative 1. And there's a negative 1. And friends, if this is the free response portion of the test, we are going to leave our answer like that. We're not going to go any further. But because I know some of you will probably keep doing it just because you will, no matter how much I tell you, I better go and finish this up real quick. So 6 times negative 3 is negative 18 divided by negative 6. That'd be, a positive 3 over 4, which would then be, friends, 15 fourths. All right, that is implicit derivatives. Obviously, the second derivatives aren't the most fun thing in the world. Not horrible, but they're not the most fun thing in the world. The first derivatives, not bad. Just follow 4 little steps. You're being great today. Hey, we'll talk more about this tomorrow morning. Have yourselves a wonderful night.